second part in our three-part series on the design of detailing of pile caps. Today, what we have in store are three main items. We are going to look at all of the code requirements for flexure, for shear, and also for detailing. And that you'll see as we go through the discussion. For those of you who may not be familiar with certain parts of pile cap design, there's always been a gap somewhat in the building codes in terms of how to actually design and detail these particular types of structural elements. And as some of you may be aware, the CRSI handbook, which was around for many years, they discontinued it in 2008 and then replaced it with a number of design guides. One of those design guides does cover pile caps. There was a procedure in there that went through the design and detailing. It did try to fill some of the gaps that were there in the building code. And what we're going to present, and it's going to follow the procedure that was in the CRSI handbook and design guide. And as you'll see, it incorporated appropriate parts of the code were needed. So for example, for shear design, it incorporated the allowable shear forces for both one-way and two-way shear. There's other parts, as we'll go over today, that were not covered in the code. And what's in the design guide, the current design guide, is there to try to fill some of those gaps. So what I wanted to say at the very beginning, you're going to see all of this come together. And what I did was those parts that were in the actual design guide based on the older ACI 318 code, I've now updated it to the 2019 code so you could see exactly how that would be done if you were needed to design according to that code. So given that kind of long introduction, I hope that was clear enough so that as we go through, I'll point all of these things out so you can have a full understanding of where we stand now if you were to design these pile caps according to the 2019 edition of ACI 318. For those of you who may not have been with us in the first session, I just want to remind everybody everything that you're going to see here is going to be based on the 2024 edition of the IBC, the 2022 edition of ASCE 7 were applicable, and the majority of what you're going to see today is, as I just mentioned, the 2019 edition of ACI 318. This is the design guide I was talking about. Now, this is based on the code before the 2019 edition that we're going to see here today. So for that reason in itself, I wanted to make sure everything is updated to what the latest particular provisions are. And we will go through all of that in detail today. So let's start with design requirements for flexure. Last time we talked about loads. We talked about how those loads get applied. We made some assumptions, and then we took the load that was applied from the supported member and distributed it out to the piles, assuming that the pile cap was rigid and that it was a pinned connection at the top of the pile. That is going to be our assumptions for all of the discussion we have today as well. Okay, that's somewhat more common than having a fixed head, for different circumstances. That certainly works out, but just so we're all on the same page, this is the assumption we're going to make. The rigid pile cap with pin connection up at the top between the pile and the bottom of the pile cap. So for flexure, once we know what the forces are in our piles, we need to determine what the maximum bending moment is. And that critical section for flexure is given in ACI table 13.2.7.1. This is exactly the same set of critical sections as if you had a spread footing. Okay, they're both listed as the applicable members for these critical sections for flexure. So if we have a column, a pedestal, a concrete wall, that critical section is located at that face of the supported member. If it's a column with a steel base plate, or if we have a masonry wall, the critical section is halfway between the face of the column and, say, the edge of the steel base plate or the face of the masonry wall. So that's why we have, in this particular case, we're going to be focusing just for discussion purposes where the location of the critical section happens to occur at the face of the supported member. So we'll be focusing on columns or pedestals or walls. This